All right, so we're back to lines and planes and all of that, okay? Not all lines and not all planes intersect. You might have parallel lines. They're coplanar, they're all in the same plane, okay? That's the first thing that we start. They're all in the same plane, and then this symbol means they do not intersect it or they're parallel to, okay? AE, line AE here, and line BF, they're parallel. They're on the same plane, that front surface plane, but they do not ever intersect. AD, line AD here, and line BC, they're all on that top plane. They do not intersect, okay? Skew lines are non-coplanar, okay? They are not parallel and they don't intersect. Fun thing about parallel lines is that they actually, the shortest distance between them at any points, it's always going to be the same thing. Whereas if you look at line AB here and line CG, they're skew lines. They're on in 3 dimensions now, not just on a 2-dimensional plane. And this one's going up and down, this one's going across like this. The closest they'll get is kind of like right there, right? And then they'll get further and further apart eventually, but they're never going to touch. And parallel planes, like this top surface and this bottom surface, plane ABCD and plane EFGH, just like the floor and the ceiling, never going to touch. Okay, so yeah, a plane and a line do not intersect or parallel. You might have this plane right here, and then this line that's actually part of the parallel plane. Okay, this line is sitting on a parallel plane, so it's going to be parallel. Any line that's on a parallel plane will be parallel to the other plane. Now, segments and rays can also be parallel or skew. Segments and rays are just parts of lines, right? So they can also do the same thing that the lines do and be parallel if they're on the same plane, or skew if they're not. If they are parallel, they are parallel. If they're on, if they lie in parallel lines, or they're some portion of a parallel line, and they're skew if they lie in skew lines. Because again, segments and rays are just portions of lines. Now, here's a figure. They're going to ask you to identify certain things, such as, oh, and it says, assume that lines and planes that appear to be parallel are parallel. This appears to be parallel to this. We can assume that it is. Normally we won't, but they're telling us we can. Okay, so which segments are parallel to AB? Where's AB? It's right here. Well, this segment is parallel to AB because it's on that plane. This segment's parallel to AB. They're both on that plane. But fun fact, so is this. GH is parallel to this one. How can that be? Are they on the same plane? In fact, they are. Look at this plane right here. Okay? There is an invisible plane running down there. Just because you don't see a plane doesn't mean there's not a plane running through it invisibly. Okay? At a diagonal like that. And so they are. So there you go. Okay? Now, let me cover that back up just to not distract you, but that's kind of a cool thing. Okay. Which segments are skew to CD, to segment CD? Segment CD is here. Okay. Well, we've got this line right here, BF, AC, AE, running up and down. Let me see if I can get rid of that. We also have EH running this way, skew to CD, and FG is doing that as well. None of them are parallel because they're on different planes, but they're not going to intersect it. Okay. Now, what are 2 pairs of parallel planes? Well, you can have plane ABCD on the top and plane EFGH on the bottom. Those are the top and bottom of the box, and we can assume they're parallel. So they're planes that are parallel. We also have, and notice they named it with 4 letters, the 4 corner letters. You can also name it, remember, a plane with 3 non-collinear points. So they say plane DCG, that's right here. That's the right side of the box. What about the left side of the box? Plane ABF. You could name it differently, but that's the idea. And what are 2 segments that are parallel to BCGF? BCGF is this back plane right there. What 2 segments are parallel to that? Well, here are 2 of them. 2 segments that are parallel to plane BCGF, that back plane. could be AD right here and DH right here. There are others that you're going to do in the got it problem. In fact, here is your got it problem. See how you do. Okay, so when you have two lines like we've got here, M and L, and they are crossed by a transversal line, T, okay, you see that there's 8 angles that are formed, kind of top left, top right, bottom left, bottom right for these 4. And then here, top left, top right, bottom left, bottom right, okay? We're talking, again, these are all coplanar, they're all in the same plane. We're talking about a two-dimensional flat surface where this line is on that same plane, so is this. And this is called the transversal. It cuts through them, forming those 8 angles, okay? What you get is that 4 of the angles are in the interior or the in-between of these lines L and M. They are interior angles, okay? And 4 of them are on the outside. They call them exterior angles. That's the big idea, and we're going to be referring to them like that. Okay, now, as you can guess, you probably want to take a few notes, but these will become actually, as you do some problems, comfortable and intuitive to you. So, first of all, there's 2 words here that we're talking about for these angles. Interior, remember that's in between the lines, and for here, it says alternate, and here it says same side. So let's start with same side. If we're talking about the interior angles, the 4 interior angles, which ones are on the same side of that transversal line cutting through them? Well, 4 and 5 are on the same line, right? That's a pair of same side of the transversal, interior part of between the 2 lines angles. Same side, interior, same side, interior. The other possibility is that they're alternate, or on either side of the transversal line. Okay, 4 and 6 are alternate interior angles. 3 and 5 are alternate interior angles. Okay, what about if they were exterior? Well, the big one that they're going to refer to are alternate exterior angles, like that. Okay, or like that. Alternate sides of the transversal, but on the exterior. Okay, they don't name it here, but you could also refer to the same side exterior, which would be like 2 and 7, or 1 and 8. Those are pairs of same side of the transversal, exterior of the 2 lines angles, okay? The last idea here is corresponding angles. Remember what I said, top left, top right, bottom left, bottom right, if you want to think of it like that? Well, if this is in the top left, what's in the top left on this bottom intersection? 1 is on the top left, and so is 5 down here. So 1 and 5 they would call corresponding. Those 2 angles correspond with each other in terms of their position, okay? Bottom left and bottom left, 4 and 8. And notice one's on the interior, one's on the exterior, okay? One's on the interior, one's on the exterior, 2 and 6, or 3 and 7, okay? You might have something like 5 here, and 2, that's not, we don't really call that any particular relationship, okay? So every once in a while you get a pair of angles that we don't really have a name for them, okay? Anyway, you might want to take those notes because we're going to need them. Okay, so looking at this diagram over here, it says, which is a pair of alternate interior angles, and it gives you these choices, okay? And you've got all of these right here. M and N are those 2 lines that are being crossed by the transversal line R. Now I'm going to move this out of the way a second so you can see this set of notes. Which choices can you eliminate? Well, what you are looking for are interior angles, so you can already right away eliminate the exterior angles as possibilities. 1 and 8, 4 and 5, okay? So anything that's got 1 and 8 or 4 and 5 over here, we can eliminate. Oops, let me just do this, move that to the front, put it there, okay? Anything that's got 1 and 8 or 4 and 5, we can just cross off. So we say, can't be that, can't be that. So it's either 6 and 2 or 6 and 7. Let's see. alternate interior angles. 6 and 7, whoops. But those are same side, so it's not going to be that. 6 and 2 are the alternate interior angles. Okay? So how about this? Oops. Use the figure up here, and what are 3 pairs of corresponding angles? So do your best to find out what those corresponding angles are. That you got a problem. Sorry, this is juggling around. Good luck. Okay, and this one just says, here's the Royal Ontario Museum in Toronto, Canada. Beautiful building. It's got all these lines that you can see. There's a couple of lines cut by this transversal here. And it says, are angles 2 and 4, 2 and 4, alternate interior, same side interior, corresponding, or alternate exterior? Well, we can see that they are both on the interior of those 2 lines and alternating sides, or each on a different side, so they are alternate interior angles. Okay, now your got it problem. 1 and 3. What are 1 and 3? What type of angles are they? Try and identify them. Okay, I'm really curious whether you're doing these lesson check problems. They're so helpful to just immediately see how you did. Low stakes because you can write them down and you can check them, and if you didn't know how, then at least that's something that you know to ask about, and that's a good thing to do in class before you get your homework. So try them, see how you do. Good luck.